Good morning, Year 10. We're still working on gradient, which we started on Friday, the 22nd of Feb. Remember, we had a look at these wonderful movies, short clips on different sizes of waves. We were using that, and we talked about that to compare the different size of our waves, and that's what gradient means. Gradient gets us to talk about different slope, different size slope. So some of the words that you would use would be uphill, downhill, steeper, gentler, and you were asked to collect 10 pictures that would show gradient in some way and put them in a Word document. And your first job today will be to send that completed Word document to me. You might have pictures of ski slopes. Some of you had cliffs. Some of you might have had a treadmill or a roller coaster. And waves. Remember, we looked at roads. I gave you some pictures and we categorised them into steep or gentle. The next picture clearly shows a ski ramp. And you can see here, and this is where the maths comes in. If this ski ramp didn't have enough gradient or enough slope, we wouldn't be able to do these ski tricks. So a lot of people would be using maths to work out what gradient they would need on their slope. The definition of gradient is it represents how steep a slope is. A gradient can be positive. So uphill is positive. A gradient can be negative, like here. So downhill is negative. We have mountain in the middle. You will learn that the gradient symbol is an M, and that's standing for mountainous. It was first brought about by René Descartes, and he assigned the letter M as montagne, which is the French for mountain. The mathematical value of gradient involves comparing how far up you go, which is known as the rise, against how far across you've gone. So it's very simply, we're comparing how far up we've gone. This is our Y values against how far across we have gone. So we use a simple formula. It's how far up divided by across. How far up divided by across. Gradient, as we said before, can be positive. So it slopes from the left to the right. So if you start at the bottom of the line, which way does it go? It goes up from left to right. It is a positive gradient. A negative gradient is a downhill. So we're starting and we're going from left to right. An interesting one is this one. This one's a zero gradient. It's flat. It's horizontal and it does not go up or down. So, for your reference book, and you can refer back to this slide, we start by gradient refers to how steep a slope is. To find the gradient, we use this formula. It is known as rise over run. How far up versus how far across. And just a reminder, the bar here is known as our fraction bar. It's a divided by. So, here's a question. This is still in your reference book. Find the gradient between the point A minus 1 and 1, and B, 4 and 4. We have a number plane. You'll notice there are certain mistakes. There's no X on my number plane, no Y on my number plane. I should have these intervals marked. Plot the points. Here, we make a triangle between the points. So we'd have a triangle. These are all the steps. The third thing you're going to do is count the rise over the run. So starting here is my rise. 1, 2, 3. Watch again. Start at the point 1, 2, 3 over my run. So let's go to my run here. Start point, skip 1, 2, 3, 4, 5. In other words, my gradient is my rise over my run, and we substitute in 3, my rise, my run is 4. And I should actually have that as 0.5. Substitute. I'm going to call it formula. So for all of the ones that you will do, these are the steps. You plot the points. You make a triangle. That should be down on that a bit more. You count the rise here, rise, run. Step 4 is write your formula, gradient, rise over run, and substitute. And I spelt that wrongly. Substitute. Good luck. Now go to your textbook. Lots of practice. All right, have fun.